Hey, it's that time, 6 p.m. on Sunday. Welcome to Steve's Place. Tonight we have a really good show. We have Mr. Will Dale here who's going to do a presentation about Tesla coils and how they are the scalar kinetic interface, and they're a good teaching tool. Um, and and anyway, I'd like to thank you for all being here. And I'd like to encourage everyone to remember we have a YouTube channel. And if you're watching this on YouTube, don't forget to do us a favor and give us a big thumbs up, if you like this material, so that it allows the search engines to find us and help us get more people watching us. Okay. And we also have like 3 sets of conferences online, and we're getting ready to put the 4th one, the conference on free energy, will be going up here pretty soon. But we encourage everyone to come and at least subscribe to our YouTube channel. Our YouTube channel can be found by going to the webpage. If you look at the little guy there, you'll see the homepage, Teslatech.info, and there'll be a yellow box, And if you go up to the yellow box, you just click on new Teslatech channel, it takes you right to our home channel there. And you can sign up, subscribe. Subscriptions are free. We'd like you all to join, if at all possible. It's $9.99 a month to join. And we have if you're a subscriber, you have access to hundreds of videos. But if you become a member, it's $9.99 a month. And we have an exclusive membership, $9.99 a month, and includes all the videos up there. We have close to 1,500, if not over that. And we have past conferences. The 2024 conferences are 2023 conferences up there. I'm working on putting the 2024 conferences up there now. It just takes a lot of work. And so if you become if you join for the $9.99, it really helps us out. It keeps things are rolling for us, Speaking of rolling, we're getting ready to move. So this next couple of weeks are going to be kind of topsy-turvy here. I don't know how it's all going to shake out yet. We're supposed to be moving out in the middle of nowhere. And so I'm not sure what we're going to be using for internet connection. The options are kind of like Earthlink, I hear, and Musk is that thing, Starlink or whatever. And then we have possibly, I'm hoping they have Quest will be out there, and I hope they will have a DSL for me, because I like DSL. The thing about DSL is that you're the only person on the line, so your signal strength is always the same. That's where on cables, more people they're on it, the slower it gets, and it kind of throws everything off, and they have to come out and they have to balance lines, otherwise you get a lot of noise on. But anyway, that's all coming up, and we'll keep you informed on how that's going. If you go to our homepage and you see this symbol here, you go on there, and that's where the 2025 conferences online. It's $99 for the whole thing. It includes all the intermissions and everything on there too. So go up there and check that out. That helps us out as well. And we also have the 2023, 2024 conferences. Like I said, you can get them either through How To, okay, or you can just go and we can get you hooked up with DVDs. And speaking of DVDs, we still have our DVDs on sale with $100 off for this year's, and we have discounts for other years. And I believe we dropped the price on last year's conference already. So if you have any questions, give me a call, 520-252-0374. And I'm also working on the 2026 conference. As soon as we get the information together on that, I'll be letting you know. We have a call for papers if you want to speak there, you need to get your abstract in right away. Okay, so with that, I think I covered everything. One other thing is we do have back issues. Here's our back issue, most recent one. It's kind of old. But as soon as I get moved, one of the things about moving will be in a place where I can spread out and I can start getting the magazine out again. So that will be the thing that we're working on. Okay. And we have a question here about interviews in between the lectures. Paul, you need to get hold of Mike at HowTube, and he will answer that. And I'll remember to call him tomorrow and ask him. Okay, let's see what else I got going. Okay, without further ado, let me introduce Bill Dell.
Hello, everyone. I appreciate the opportunity to come and talk to you tonight. My name is Will Dale. I'll be talking about Dale Pond's Tesla coil conceptions. It's going to be, this talk is created from the volume 32 of the vibration series for Dale Pond. It'll be on his Patreon page. You can go see him. And the big deal that starts out is Dale's idea is that you're going to take scalar potential to kinetic motion and back to scalar potential, and that's going to be your building and release of energy, and then the return of that energy back to building up and releasing again. So scalar potential, you can think of that as a lot like a potential of like a calm lake or something like that. You know, you've got still water. Maybe if there's a dam there, you open up the gates. Now you got a lot of movement and action, and things are very different. So scalar potential is a lot like that. It builds in the background, and you don't really see or observe anything until it starts to kick into motion. That's where, in this case, that's where you're going to be your spark gap is going to trigger that. Then you get the effects going through the coil, and once that discharges from the coil, then the whole system turns back to the recharging stage again. And if there are any questions along the way, go ahead and feel free to ask, and we'll keep it going. All right. We're going to go through like just the basic anatomy of a Tesla coil. You got from the bottom down, you got your primary coil. It's going to have two sets of resonant coils, your primary coil and your secondary coil. The construction of a resonant coil is going to have that coil and then the capacitor that builds it up, and then when the spark goes, it enters into an oscillatory condition. The energy in the circuit will oscillate back and forth, which then causes vibration in the coil. And then that coil, the primary coil, will inductively excite the secondary coil. And if you get the harmonics correct, you'll get some interesting outputs. You can get really interesting stuff like sparks and things like that. That's what most people are familiar with when they think of Tesla coils, are the big lightning sparks and arcs that'll come off of them. But that's only one version of what you can do to tune them. And Dale's idea is that if you use because they're resonant circuits, and if you use more of a musical harmonic type tuning, you're going to be able to dial them in a little better and get different effects that could be useful. All right. So Dale, he likes to talk about the how it kind of behaves like uh, a living system. It breathes in and then discharges, breathes out. So he's got it described in that manner. So he goes through the charging, and then it differentiates, and then comes into sympathy between the resonance of the two coils. The secondary coil magnifies the signal, and then the antenna, the top load, is where you get to release the arcs or plasmas and things like that. Then we start to get, losing my place just a little bit. All right. Then he gets into the neutralities. Yeah, he talks about two neutralities: neutral center, neutral void. So again, a lot like getting into Russell, where you've got the rhythmic balance interchange, the seesaw. So you'll have 2 points of null motion. So at the top and at the bottom and on both sides. So there's at each point of a seesaw oscillation, they're going to stop momentarily and then reverse direction. So you have that momentary effect of those neutral centers, kind of an analog to that. Then he goes into the music intervals and tuning it using the music intervals. You'll get better resonance and sympathy rather than trying to just manually tweak the input signals to get resonance. You naturally get resonance using music ratios. So he goes into talking about how and why he thinks that they relate to Keeley and Russell and Tesla and cross-linking between the three of them. Um, Russell has the rhythmic balance interchange as well, and as Keeley talks about similar principles with sympathetic vibration. Tesla, he talked about similar principles and worked on similar principles in the way that he was tuning and using his Tesla coils. He was using the high vibration, high frequency, and like radio ranges and things like that. And it comes into play when you're also tuning the receivers and the effects that you get, not only in the materials but in the uh, electronic effects. Dale does clarify that he doesn't see that this is a bridge to free energy per se. That's not what he thinks this particular application is going to be for. At least this type of build for the coil or design for the coils. He doesn't believe that that's going to produce any necessarily over unity or free energy, but that you might see synergistic effects that are more efficient and behave differently than uh, less harmonic effects. Right. So also he talks about how it recycles energy. It's got the balanced interchange between the resonance of the coils and the discharges, and then rebuilding. Some of the effects that he talks about are quiet field mode. The top load side would have reduced sparks uh, and more of a corona type discharge, smooth. Um, those are some of the hypotheses that he put out there.
It will.
Yes, sir.
Are these corresponding with your slides?
I'm on. Where am I? I'm on slide 9.
Okay.
We're getting down to talking about demonstrations and research.
Okay. We'll go back through here later on and with the slides and everything, and people can see better what you're talking about.
Right
Okay.
on. So in a lot of demonstrations and stuff, you can see people lighting up uh, light bulbs and fluorescent lights and things like that. So you get to do that kind of fun stuff. He talks about one wire sympathy. That's a
Okay.
and then some of the other more speculative things where he talks about um, how applying applications that you get out of it, it can be applied towards communications and things like that, where you may be able to have more stable communications, secure communications by using harmonics and harmonic residues and things like that, without getting too in depth with how that stuff goes. And also electrical experiments with effects on seeds, plants, how they grow, and all that kind of stuff. And then he goes into the safeties and ethics of things, high voltage you're dealing with, and ozone. The coils can't produce ozone, ionizing the air. If you breathe it, it can burn the lung tissue, so that's not a good deal. So you want to make sure you get plenty of ventilation, things like that. Of course, you're dealing with electronic fields. If you can light up a light bulb, it can light up your pacemaker. So if you got a pacemaker, you might want to think about maybe a slightly different experiment. And of course, with electricity and sparks, you got to think about fire hazards and things like that. But as long as you take the proper precautions, a lot of people have a lot of fun with it, and you can learn a lot by investigating exactly what's going on, how how it interacts. So we can learn from the coil. It can be a teacher, and if you want to know more about it, a lot more, Dale gets a lot more into the details of what scalar kinetic transfer is. Uh, so he gets into the nitty gritty of it. That that volume 32, I think, is about 75 pages long of just in depth. We got some schematics, just kind of give you a rough idea of the where the parts are and how they go together in the Tesla coil. At the bottom there, you've got the spark gap, which is not connected to the primary coil, but in a real schematic, it would be. That is not connected to the secondary coil. They uh, they excite each other through the induction process, and then the top load or the antenna at the top. And I got another one here, gives a little bit different view. This one's got the toroidal top load. Giving off some sparks. That's what most people are familiar with. You got a couple of different common coil types, spark gap coil types, and you got solid state coil types where the switching is controlled with chips. I think what we got usually I don't see that. If I had a note there on which kind of chips, but I don't see it. That's okay. All right, I think I did a quick run through. Is there anything that anybody wants to know more about?
I'd like to go back to the top there because I was kind of missing a lot of stuff.
Mm-hmm.
But anyway, I guess Dale's big idea is that he has a scalar potential here in the coil, okay? And the coil takes that scalar, the voltages in that, puts it in motion with current in that, okay? And that will release the scalar energy or return scalar energy of whatever.
Mm-hmm.
These coils are all of all sizes, okay? The basic Tesla coil, okay? Let's see. And here's the different aspects of the top load, the secondary, the primary, the spark gap, the tank gap, and the ground. The ground is very important. Um, I don't think you built a Tesla coil yet. If you ever get to my place, we can maybe take that on as a project. Um, One time I was working on a Tesla coil. my friend brought over and he was showing me and everything. And we were smelling smoke, you know.
Oh no.
We weren't getting any sparks, and we were smelling smoke. And all of a sudden, the back of my pants got really warm. And what had happened is, somehow, um, it was shortened from the tabletop to my pants, okay, and then down to the carpet, and the carpet was catching on fire, you know. So you got to be really looking at this stuff, you know, and like on a lot of times the secondaries, you know, they use like a big flat pancake coil, and with
Mm-hmm.
that pancake coil, you can take a wire and you have like the wire and you just move it along that pancake coil. Just be careful though, because that um, that primary can carry a lot of current, which will kill you, you know.
Yeah.
And here's the biggest coil, one of the biggest coils out there. Uh, this
Okay.
I think this was the extra coil he's used on this, and you can't really see it here, but there's like a huge 50-foot primary with a fence-like secondary above it that feeds into this thing, you know. And this
Wow.
is what Bob Golka built, you know, uh, on a contract with the Air Force where they're studying lightning on planes and everything. And so that is huge. I mean, um, and unfortunately, Bob is no longer with us. He was supposed to give a talk in 2018. Uh, Unfortunately, 3 months before the talk, he passed away. Uh, so, this shows you how short life can be and how unexpected it is. But he had built this in Wendover, Utah, in the hangar of the Enola Gay. And for people who aren't up on their history, the Enola Gay is the plane that carried the first nuclear bomb or atom bomb that was dropped on Hiroshima. Okay,
Mm-hmm.
in the 40s. And this is the hangar they exercised, and then Bob had built this huge testicle in there, like 50 foot wide. And those arcs are, you know,
Wow.
pretty wild, you know. And there's nothing like a Tesla coil, you know. And it's one of the basic things, you know, we should all strive to be able to build, you know. And like they're very easy to build. Um, you could build them out of junk, you know. Uh, we've done things like, you know, like when you have a water softener and you have like the inner core of that fiberglass thing, that makes
Mm-hmm.
it form to take, and you can wrap your secondary on that uh, using, well, that size area. We use like automotive wire that you have, you know, go and Napa and buy, you know, and use that for your secondary. And you can, if you have like a refrigerator laying around, rip the copper off to make that primary around the big coil in the back on the bottom. So that's your primary coil and your secondary coil. Spark gaps. It's just basically have like two two metal pieces close to each other where a spark can jump across. That's your spark gap. And by adjusting the spark gap, you can adjust the tuning. Bill Wysock, he was one of the greatest coil builders of all time. Unfortunately, he's another one that's passed away. Uh, and he actually put them inside of a uh, plexiglass gas chamber he had, so you can adjust the gases in there, you know, and have different atmospheres, because
Oh.
will function different in different atmospheres, you know. Uh, and so, like, you know, there's just a lot of good things, you know, on Tesla coil. A lot of technology you can experiment with. Um, the tank capacitor down here, uh,
Mm-hmm.
the we used to get like You know those dish pans with plastic uh, containers, you know, you have to rinse your dishes in, you know?
Mm-hmm.
Yeah, you can take and fill one of those up with oil. Well, actually, you put a piece of glass, you know, like a window glass and that, and you put a piece of metal on it, you know, and
Mm-hmm.
you just have layers like that. And on one side, you know, you have every other one hooked up with one wire, and on the other side, you have the other one in between hooked up on another wire. Okay, so it kind of like you're going like kind of like this, you know, and so your arms would be each two different wires there, you know. So that makes a capacitor, you know, and then
Yeah.
pour oil over to uh, keep the spark from shorting out on the sides of the thing, you know. And we made capacitors like that. Tesla used jars. He used to have jars of salt water, you know, and the salt water he would use in lieu of the paper, you know, but or the metal rather. Yeah, so there's all kinds of way to make capacitors and everything, you know. Uh, Tesla coil construction, okay. Uh, you can use all kinds of junk. You can be very innovative on it. It's where if you're a kid into experimentation, you can shine, you know. I mean, this is a place you could play with, you know. But the key to it is getting back to the spark, you know. Now,
Mm-hmm.
now what Dale's talking about here, okay, when he's trying to do the scale potential kinetic motion return to scale and that, but I bet his, yeah, on this one here, um, Tesla devised these to transmit power, okay, and
Mm-hmm.
had a spark that was a waste, okay,
Right. He talked
and
about like quenching it with magnets and stuff like that to try to get it to stop as fast as he could.
yeah, and what you want to do though is you got to take and for power transmission, you don't want the spark. You should be transmitting the whole power through the ether there. Okay, that's the whole thing about it. Um, and but us coil guys, you know, we glorify in the spark, and that may be detrimental to our health because the spark gap and the spark coming off the top and everything. Um, you got to understand, you know, that spark is putting out a lot of UV ultraviolet. Okay,
Mm-hmm.
massive amounts, you know. So that could be why our greatest coil makers are no longer with us. You know, they have something to do with that. You know, um, yeah. So
For
work
sure.
with this stuff can be dangerous if you don't take precautions. You know, at our conference, okay, we tend to put like a shield in there, which would kind of block some of that UV and everything, you know, from the audience and that. But I find this kind of interesting how he has this the breath of the coil, you know, where it inhales and exhales, charge, differentiate, sympathy, you know.
Mm-hmm.
And we never ever talk about sympathy. I wish Joe was here, where we could talk more about the sympathy thing, you know, or what are your thoughts on the sympathy aspects, or have you messed with that much?
Sympathy basically with sympathetic vibratory physics has to do with harmony or concordance. So just like with tuning forks, if they're in tune with each other, you strike one, and the other one will begin to vibrate in sympathy with the first one. So that is a kind of concrete example of what sympathetic vibratory initiation is.
Okay, so if you have like the primary, which is the big coil,
Mm-hmm.
the on the bottom, which carries the current, and then you have the secondary, which is generally in most coils, well, in a lot of coils, is the thing that stands vertical there. That
Mm-hmm.
will magnify the voltage, okay, through sympathy.
Right.
and it magnifies it. And then on top is the release.
Yeah, same
The spark.
principle as like passive amplification in acoustics, but it's not quite passive in electronics. It's a little different.
So, and then of course it comes back to becoming still again before it gets charged up again.
Mm-hmm.
I think everyone out there should try to build a Tesla coil. I used to have a book called Tesla Coil. I'm going to see if I can find that book, a copy of that. I might have one here. It was written by George Trinkus. A very simple book, explains each one of these components in detail and how to build them out of scrap. Okay,
Right.
I'm a waste not, want not kind of guy. Okay, and that's why I like about a lot of stuff we do. I've done is always with scrap. Okay.
Here,
Now
here.
here's the thing: I don't really have a grip on is these neutral centers and the balance flow. So, do you want to go over this neutral thing again, or you
Neutral
say?
center. A lot of times in the SVP, the neutral center is going to refer to Dale again. He'll talk about seesaw, right? And so for a seesaw, both sides go up and down, but the fulcrum doesn't. So
Okay.
that's kind of a example of a neutral center. Is you have dynamic action, you have kinetic action, but the neutral center is not actually translating anywhere. You might have vibratory action, and in that case, that neutral center, you have some rotational movement, just not translational up and down movement. So that's where neutral centers come in. They will they vibrate, but they don't translate. They don't oscillate.
Okay, so you have neutral center, you have neutral void, and the musical tuning. Um, I never really tuned with music. Uh, Closest we came is like when we moved that one wire around the primary till we found the maximum spark. You know, which well, you need to either be wearing insulated gloves and wooden shoes, which are dangerous, or turn the thing off, move the thing, then try it again. See what you come up with.
Right.
That's the safe way of tuning. You know, but we did it by the length we could get the. We'd be going with for the dissonance instead of the harmony. We'd be trying to, because if it was in harmony, we shouldn't get the spark. Okay,
Right.
and the dissonance is the chaos and everything.
Where you get it to break out. Yeah.
But it's in the dissonance. Okay, that is where you get the power. Okay, that the free energy guys are looking for. Okay, in the end, we're always, Tesla was always looking for the disruptive. Okay.
Dissonant signals actually can knock systems out of their current level of resonance, and then they will reorganize into another level of resonance, usually higher. So that's one interesting aspect to that, is that the chaotic signal disrupts the more orderly signal, and then it reorganizes into an even more orderly signal.
Well,
That's something they're finding in like AI training and things like that.
Well, as an engineer, okay,
Mm-hmm.
what we're trained, with all of our math and everything, is we're trained to always try to get the harmonic signal there, the harmony signal, the steady state, okay, and that's okay, for most applications. But when we're looking for free energy, and we were looking for a lot of transients, and if you ever heard of these Tesla coils that sing, the way they sing them is they'll take like feed an audio signal into the primary, okay, um, and they'll take the audio signal, and then the top thing where the spark is, that spark becomes the uh, what do you call that? The speaker.
The speaker, yeah.
Okay, so what you hear, like you play a record, and all the sound come out of that spark, but it's a very tinny sound. Okay, and it fills the whole room. It's really weird, but you can tell it comes from one spot. It's a weird experience. But the best music to use for that is Bach, because Bach has a lot of transients in his music. So it really works great, on a Tesla coil if you're trying to make it sing.
I've actually heard Eric Dollard talk about that specifically.
And we have a 1987 DVD on free energy we sell where Eric Dollard is giving a lecture, and I'm in that video, by the way, as that observer.
Perfect.
He ends up playing a musical Tesla coil, and that's how I know all this stuff. I was there listening to him. I actually listened, and it was very beautiful. And we have that all on a DVD. So yeah, this is comes in very, very much so, and it's amazing how electricity, electric theory, and engineering and music is intertwined in a lot of levels. Unfortunately, a lot of it you have to learn on your own. Because they haven't formalized it into like courses and that. Even though we use it all the time as engineers, we just don't realize we use it. If you know what I mean.
Right. Yes.
And it's amazing stuff we have out there.
Well, Keeley and Tesla and those guys, they were using the laws before they were recognized or codified. So.
And Dell is one of the most knowledgeable people I know on this stuff. Jerry Ducker is another one, but there we go again. I encourage you, if you guys ever get a chance to come to our conference and we have these guys speaking there, come and visit them. I mean, come and see these people in person, because these bodies we wear, they're just temporary, and we're very fragile, and we could be here today and gone tomorrow, and you don't even know what's going to happen,
Dale is prolific in his research, his knowledge is encyclopedic. Talking to Dale is an experience.
And Dale, I know he could always use donations if we ever get a chance. Go get it. Maybe go get some of his books and that, and we have the link there on the back, at the last page there. But anyway, you could use the help and everything, and you could use the knowledge, So it's great how he has this cross links here, because like Tesla was a hardware kind of guy. This is where most of my focus would be is hardware, And then we have Russell, who introduces the geometric aspects, or focuses on the geometric.
Right.
What a lot of people don't seem to realize, is that a lot of the test inventions are based on geometry, and they're very symmetrical in their construction, you know. And like the primary, and some like Tesla cores have the primary, which is on the bottom, and then you have like the secondary that rises out at a 90-degree angle from that. Well, it's kind of like simulates a vortex. Okay,
Mm-hmm.
uh, it's that kind of structure. You know, so symmetry has a lot to do with it, and geometry has everything to do with it. You know, and that's where Russell comes in. Then he has Keeley off to the side as far as vibrations, and uh, we don't really spend. Well, we spend a lot of time work with vibrations in engineering school and that, but we don't call it that, you know. And vibrations are always has a frequency related to it, you know, and they're
Mm-hmm.
always cyclic in nature, okay, more or less, you know. But then again, unless you get a disruptive circuits, you know, and disruption causes all these transients, and in transients is where an infinite amount of energy can actually come through is a transient or an impulse.
Right.
You know, the impulses, you know.
Yeah.
And the trick is,
Eni talked about that a lot. But with Tesla, like you were saying, he's the hardware guy. He's the phenomenologist. He's getting his hands dirty. Russell, he's working with the shapes and the proportions geometrically. Keeley, he's working with proportions uh, musically, which also pertain to geometric proportions. That's where we get Pythagorean tuning from. So those two things link together. And then Tesla was a phenomenologist, and he was the one working with all of it to see what it actually did when you changed all those things.
what test is the mechanical implementation of a lot of the theory that Keeley and Russell had. It's kind of like
Mm-hmm.
on your cell phones today. Uh, they have like different generations. What that generation refers to as the actual circuit. Now, when I was in my senior year in college, I did a lot of graduate level work on communication theory, and would have these long equations that could cover a whole page, you know, and everything. And what people don't realize is that a math equation has a mechanical equivalent as a circuit, you know, and um, you have an integration sign, okay, an integral sign would be like a capacitor, okay, and they don't really teach that in they're going through this math, okay, all these classes of math, and it really don't come together until you start doing communication theory at the end there. Then you start seeing how all this meshes together, you know, and how you have different things like, you know, a coil is actually a differentiator, you know, so that would be your delta, you know. So
Right.
so all these equations, you know, they actually have a physical um, a
Analog.
corresponding physical model
Mm-hmm.
which we build. And like on these chips, okay, we take the whole equation and we convert it into a mechanical thing, okay, on chips now. And we tend to work with capacitive circuits because it's easier to build a capacitor than an inductor on a chip, okay. So so the chip that's in your phone takes and it takes a ton of information, it compresses that down to practically zero. That's what gets transmitted. It goes to another phone where you have a corresponding circuit that takes that signal and blows it up into what you hear. So that's how we're able to pass these amounts of information on these phones these days. And we have things like video and everything, you know. That's where it all comes back to the math and everything. And actually, these three guys here, Tesla, Russell, and Keeley, and how they all interact together. You know. So let's look at another one here. The myth versus reality. Okay, I disagree with them. Well,
I think he's trying to be careful and not overstate and just.
he says it's a free energy device is a myth. Well, that's a half truth. Um, it depends on how it's configured and everything. Okay, by itself, it can't be a free energy device. But when you
Right.
configure it and you start throwing in things like extra coils and that, everything changes and it can be part of it. Okay, and and that Tesla coil is only for fireworks and lightning shows. I agree from there because you can look in your car, if you have a internal combustion engine, okay, and you have a spark plug with a whole ignition system, spark plug. Well, like on an 8-cylinder engine, it'd be an 8-headed Tesla coil, okay, and it's the most basic thing, and it has no different. And Tesla coil is the basis for everything. I mean, what it is, it takes uh, has low frequency, low voltage, and increases it makes a high voltage, high frequency, okay, converter. It's a basis for everything. Your TV, your radio, ignition systems of cars, for example. So it's has a very important piece of equipment here. Okay, now reality. It recycles energy. That's what he's trying to explain here. It's a living instrument for studying hidden flows. You know, and it bridges science and symbolism.
I think that gets into what you were talking about. And two, is that going to be um, getting into nonlinear oscillation control theory when you're adding the multiple coils?
Yeah, and nonlinear stuff is the worst stuff because um, a lot of nonlinear tend to be transients, and transients is very hard. Okay, very hard to do because they're transit. Sometimes they appear and sometimes they don't. You know, and if it was a transit, it'd be steady state, and the steady state's easier to study and come up with theories on. You know, and that's a come. Uh, if we're going to have a breakthrough in like free energy, it's going to come from the transient side of equations. You know, so and I don't know if AI can even have a handle on transients, because if it's something that's kind of unpredictable, and our goal is to take the unpredictable and make it predictable,
Right.
then that's where we need to be, you know. And I talked about before a past podcast about Tesla's car and how we built. Um, this guy showed me how to build this free energy device, and we were extracting energy from somewhere, but it only lasted for 2 weeks and then it died.
Uh,
Well, but see, the thing is it was very hard to get to do what we saw it because this guy has. I mean, when he get in there, he seemed to have like a feel for things, and he like when he spray coils and that. He's one of these guys who can make things happen. People ask me if he was a witch or something. I don't know, but he was able to do that where a lot of people couldn't. Um,
yeah.
and and I believe that's where the our own physical being starts interconnecting with our circuits. And sometimes it's just like dowsers. Dowsers can let the energy flow through them. Okay, and that's how that works. It is dowsing. Okay, and being able to decipher that flow. Some people can do it. I don't think most people can. They may try, but it takes
I think more people could do it than realize. I think it's a matter of, I think it's a sense, just like hearing or smell or taste or touch. Um, and if you ignore it or never use it, if you're born and your parents blindfolded you, you'd be blind, even if they took the blindfold off. By the time you're 10 or something, you
Well,
never learned all the micro movements and developed all the muscles for focusing in your eyes. You'd see blurry stuff, but you probably would never learn to see very well. You
that's has a
know?
lot to do with it, is and if you hear something, like if you hear the same sound in the background all the time, all of a sudden you don't hear it anymore. Or you walk in a place that stinks, you know,
Yeah.
your nose becomes desensitized to it, and you ignore
Right.
it. And that's what happens to a lot of this. And that's how come kids can see things, like ghosts and that, because they're there. I mean, I believe, and we live in a multi-dimensional world, but it's just going between them, and that's kind of like this Tesla coil is supposed to be doing. Okay, and then yeah, I was wanting to see this. Maybe someday I will. Tuning by fifth. Hear the bell like ring. I've never seen that done. Yeah. Uh, so
I've not seen it done either.
so I have to get with Dell on that. That'd be something he could work on. Yeah,
For
a
sure.
demonstration that we do online here. Yeah, or bring to the conference, which would be even better.
That'd be great.
So yeah. Anyway, I hope
That might be my project this year.
I encourage you to first build a Tesla coil.
Right.
See if you can locate a book online. It's called Tesla Coil.
Oh, okay. That's easy to
Hard to
remember.
remember. The trick is the author is George Trinkus, Trinkaus, and unfortunately, George is no longer with us. And the problem we have is like when these people leave, um, there isn't a good mechanism for them to pass that knowledge on, and generally the families get it. And then all of a sudden it gets locked up again because they're all trying to cash in on it, you know.
Yeah.
And I see it over and over and over again, you know. And and it's very hard to deal with people who inherit stuff as opposed to people who actually worked with it. Because the guy who invented it and that like to see his stuff carried on, whereas the people who follow just want to cash in on it.
Yeah.
It's a shame. Yeah. So let's see what else we got. The safety and ethics can't. This is a new one though. Medical implants may interfere. We never paid much attention to medical implants, but now it's so commonplace.
Might be a little bit more relevant these days.
Yeah, and well, it's just not like medical implants. What may happen? Well, like we had a big demonstration, at this hotel, where this guy was sitting on top of his table, and he'd be have an arc flow over him, a testicle outlet flow over him, and then through this wire and through this light, and then the sparks would come out. So it would be impressive,
Right.
We did it one time, and all of a sudden, when we turned that thing on, the hotel fire alarm went off. It stopped all the elevators, turned off all the gas to the hotel, and the hotel come running down there. They figured it was us and told us we can't do that anymore.
Yeah.
But then about 2 hours later, they come back and they said, okay, we can do it, but we have to do it on a schedule, and their manager has to be there when we do it. Because what he would do is he cut off the fire alarm and prevent everything bad from happening. We still got our picture. And they did that because we were getting so much publicity, at the hotel, and this is a new hotel, and they had a very powerful enemy, the old hotel. And none of the news places, outlets would cover events there, but they covered our event. So they wanted that publicity, so they came up with a solution.
There you go.
People are, when money's involved, people can always come up with a solution.
Yeah, mutually beneficial.
Yeah. So anyway, I'm going to undo this now. Okay, so, oh yeah, and this is pretty impressive. And I seen them when he moved us to Leadville. I saw it in person. Okay, the big coil and everything. Patchy did an article, and that brings me to something else I like to talk about is our magazine. We cover a lot of material in detail. Okay, this one here we have something about Tesla Lab. So it's if you have any questions, be sure to give me a call 520-252-0374 or call office 520-463-1994, and that will get to me. So, and I'd like to encourage people to just be looking for your email next week, because I'm not sure about our show scheduled for the next couple of weeks until I get this move sorted out and out of the way. Next week is the 2nd, so we have a time change too next week. So don't forget that. If I can, I will, but I will let you know through the email. And who knows, if we're in the new spot, I might just do a walkthrough on what our new facility looks like. I'm so excited I need to get out of here, because I'm on the 2nd floor. I fell about a week ago, and I'm at the point where when I'm going up steps, I have to practically crawl up, and my knees hurt so bad, So I gotta get to a place where it's all one level, So anyway, thank you all for coming, and thank you for being here, Will. You did a great job, and
Appreciate it.
Hang around us, and we'll get you to be a super expert on everything.
Look forward to it.
Okay. And anyway, I tell Dell I said hi. And with that, I'm going to call it a wrap, and we'll see you all next week. Don't forget to sign up for our YouTube channel. We really appreciate it. Don't forget to hit the thumbs up, because that really helps us. And we'll see you all next week, hopefully.